At 4:42 in the morning, the harbor is still dark. The engines are already running. Steel cables coil tight on the deck. Water pushes against the hull. No one speaks. They already know what needs to be done. The vessel is 78 feet long. Twin diesel engines. 4,000 horsepower. Built for one thing: moving ships that cannot move themselves. The hull sits low in the water. The bow is reinforced with rubber fenders 3 feet thick. The radio crackles. A container ship is approaching the outer breakwater. It's 1,400 feet long, 150,000 tons, loaded with cargo from Shenzhen. It cannot dock itself. That's why the tugboat exists. The captain stands in the wheelhouse. 42 years on the water. He watches the ship's lights move closer. His hand rests on the throttle. The deck crew checks the towline. 2-inch braided steel. Rated for 300 tons of pull. The engines idle at 800 RPM. The propellers are bronze. 6 feet in diameter. Designed to reverse thrust in seconds. The vessel can push or pull from any angle. That's what makes it effective in tight harbor spaces. The container ship enters the channel. Its bow wave creates a rolling surge. The pilot ladder hangs from the starboard side. A harbor pilot climbs up. He will guide the ship. The tugboat will provide the force. The tugboat moves into position, 15 feet from the ship's hull. The deckhand throws the messenger line. It arcs across the gap. The container ship's crew catches it. They pull the heavy towline across. The towline secures to the bollard. The captain adjusts the throttle. The engines rise to 1,200 RPM. Water churns white behind the stern. The tugboat pulls at a 45-degree angle. Slow, controlled, precise. The container ship begins to turn. 1 degree, 2 degrees. The tugboat maintains constant tension. If the line goes slack, it could snap back. If it pulls too hard, it could damage the ship's hull. The captain knows this balance. The water depth here is 42 feet. The container ship draws 38 feet when loaded. 4 feet of clearance. The harbor bottom is dredged constantly. Silt accumulates. Channels fill. Tugboats operate in margins measured in feet. A second tugboat approaches from the stern. Same size, same power. It will push while the first pulls. This is standard procedure for ships over 100,000 tons. 2 tugboats, 2 captains, 1 coordinated movement. The stern tugboat positions its bow against the ship's hull. The rubber fenders compress. The engines engage. It pushes with 2,200 horsepower. The container ship's stern swings slowly to starboard. The turn continues. The dock is 300 yards ahead. Concrete pilings. Steel cranes. The berth is exactly 1,430 feet long. The ship is 1,420 feet. 10 feet of tolerance. The tugboats will place it within inches. The wind picks up. 12 knots from the west. It pushes against the ship's exposed containers. That's an additional lateral force of 60,000 pounds. The tugboats compensate. They adjust angle and power continuously. Radio communication is constant. The harbor pilot calls course corrections. The tugboat captains acknowledge. 1 degree port. Half power stern. The responses are immediate. There is no delay. The ship is moving at 0.3 knots. That's 18 feet per minute. The ship is 100 yards from the dock. The bow tugboat releases its line. It moves to the stern. Now both tugboats push from behind. The ship's momentum carries it forward. The tugboats control the final approach, 50 yards. The crew on deck throws heaving lines to the dock. Dock workers catch them. They attach them to the ship's mooring lines. 5-inch diameter. Each line weighs 800 pounds. They feed through the BOLLARDS. 20 yards. The tugboat's reverse thrust. The propellers spin backward at full power. The ship's forward motion slows. 10 yards. 5 yards. The hull touches the rubber dock fenders. Contact is gentle. The tugboats hold position. The mooring lines tighten. The winches engage. The ship is pulled tight against the dock. The tugboats release. Their work is complete. Total operation time, 42 minutes. From open water to secured berth. But the tugboats do not rest. Another ship is already waiting. A bulk carrier, 60,000 tons. Inbound from Vancouver. It needs to dock at Pier 19. The radio crackles again. The engines are already running. This is Los Angeles, the Port of Los Angeles. It handles 9 million containers per year. 40% of all cargo entering the United States arrives here. Every container, every vehicle, every piece of machinery, moved by tugboats first. On the East Coast, it's the same. New York, Savannah, Baltimore, different harbors. Same operations. Tugboats operate 24 hours, 7 days, no holidays. If ships are moving, tugboats are working. The crews work in shifts. 6 hours on, 6 hours off. A tugboat captain earns between $90,000 and $120,000 per year. The deckhand earns $60,000 to $75,000. They are licensed. They are trained. They are essential. The engines require maintenance every 500 hours. Oil changes, filter replacements, bearing inspections. The propellers are pulled and inspected annually. Any damage, anywhere, they are repaired immediately. Downtime costs $10,000 per day. The tow lines are replaced every 2 years. Each line costs $12,000. The rubber fenders last 5 years. $18,000 each. The cost to operate a single tugboat is approximately $1.2 million annually. But without tugboats, ports stop. Ships cannot dock themselves. They cannot maneuver in confined spaces. They need external force. That force comes from diesel engines, bronze propellers, steel cables, and crews who know exactly what they're doing. In heavy weather, operations change. Wind above 25 knots requires additional tugboats. 3 instead of 2, sometimes 4. The forces increase exponentially. A 50-knot wind can push a loaded container ship sideways at 3 knots. Fog is different. Visibility drops to 50 feet. Radar and GPS become primary navigation. The tugboat captains rely on instruments, but they also rely on feel. The resistance in the tow line, the vibration through the deck. The sound of water against the hull. Ice is rare but possible. In northern ports, Boston, Portland, when the harbor freezes, icebreaker tugs are deployed. They have reinforced hulls, extra plating. They cut channels through the ice. Other tugboats follow. Ships follow behind them. Some tugboats are specialized. Ship docking tugs, escort tugs, salvage tugs. Each has different equipment, different capabilities. Ship docking tugs like these have rotating propulsion systems. They can push in any direction without turning the hull. The newest tugboats use azimuth thrusters. The entire propulsion unit rotates 360 degrees. This provides maximum maneuverability. A single tugboat with azimuth thrusters can replace 2 conventional tugboats. But they cost twice as much. Training takes years. A deckhand starts with basic seamanship. They learn knots, lines, equipment. After 2,000 hours at sea, they can apply for a mate's license. After 4,000 hours, They can apply for a captain's license. The licensing exam is comprehensive. Navigation, radar operation, ship handling, emergency procedures, weather interpretation, mechanical systems, maritime law. The pass rate is approximately 60%. It requires both knowledge and experience. Safety equipment is mandatory. Life jackets, fire extinguishers, emergency position indicating radio beacon, lift-raft, flares. Every piece is inspected monthly. The Coast Guard conducts unannounced inspections. Violations result in fines. Repeat violations result in license suspension. Environmental regulations are strict. Diesel emissions are monitored. Oil discharge is prohibited. Bilge water must be processed through separators. Any spill must be reported immediately. The fines start at $25,000. They can reach 1 million. Communication protocols are standardized. VHF radio. Channel 16 for emergencies. Channel 13 for bridge to bridge. Every transmission is logged. Every command is acknowledged. There is no ambiguity. Clarity prevents accidents. The work is repetitive. The work is precise. The work is necessary. Every day, every ship, every dock. The same procedures, the same caution, the same attention to detail. Because one mistake can damage a ship worth $200 million. Automation is advancing. Some tugboats now have dynamic positioning systems. GPS and thrusters maintain position automatically. But automation cannot replace judgment. It cannot account for wind shifts, current changes, unexpected obstacles. The captain still makes the final decisions. The future includes autonomous tugboats, remote operation from shore, no crew aboard. Trials are underway in European ports, but full autonomy is years away. The technology works in controlled conditions. Harbors are not controlled conditions. For now, the work continues as it has, manually, physically. Tugboat captains position their vessels. Deckhands handle the lines. Engines provide the power. The ships move. The cargo arrives. The economy functions. It's 1100 hours now. The sun is high. The harbor is busy. 6 ships wait at anchor. 3 are docking. 2 are departing. The tugboats move between them. Constant motion. Constant work. No time between assignments. A tanker approaches. Crude oil. 80,000 tons. From the Gulf, it needs escort into the harbor. 2 tugboats flank it. 1 port, 1 starboard. They don't tow. They escort. Ready to push if the tanker loses steering. This is the reality of American ports. Movement requires control. Control requires force. Force comes from tugboats. The vessels are small. The impact is enormous. Without them, international trade stops at the WATERLINE. The crews understand this. They don't think about economics. They think about the next ship, the next dock, the next towline connection. The work is immediate. The work is physical. The work is what they do. The ship does not stop. Another port waits. Another load waits. Another crew waits. The engines run. The water moves. The steel cables hold. This is how movement never ends.